So using dimensional analysis, derive the unit for the gravitational constant G in the expression where you've been given uh, the equation, the force of attraction between two bodies. F is equal to that. Do we jump this question? I suggest we jump because it's not difficult. Do we look at it generally? Let me get your views. Okay, so then B. Using suitable diagrams, explain how the following quantities can be obtained from a velocity time graph of a linear accelerated motion. Okay. B isn't also difficult because if you have velocity time graph to determine if you have a uniformly accelerated motion to determine the acceleration of the body, it is the slope. It is the slope, and then to determine total distance, it is the area under the velocity time graph. This isn't also a challenging question. Then C, given that U is the velocity of a body at time t is equal to 0. Audrey. Audrey, go
Sir,
ahead.
please, can you, sir, sir, please, good morning.
Good morning.
Sir, please, I don't understand B, what you said. Please, can you demonstrate it on the board for me?
I can, but I was just keeping thinking that it's not challenging. Okay, so if you have a velocity time graph for a uniformly accelerated motion, okay, for uniformly accelerated motion from the origin or starting from whichever point. This is the kind of motion where the body begins with a velocity of 0 and then uniformly accelerates to a certain final velocity. So if I have this A, B, this connects to a time this. If this is how the motion looks like, then the acceleration of the body, okay, the acceleration of the body is the slope. The slope is equal to the change in velocity over the change in time. So we are looking for this line, this gradient AB. Then, so this will give you the acceleration. Then the area under the velocity time graph, okay, gives you the distance. So this area, because it's a triangle, half times the base. Okay. If this is maybe maximum t, the base is t, then the height is the change in velocity. So change in time for the change in velocity, delta v. So you draw this, okay, and then explain that the slope is equal to the acceleration, whereas the area under the velocity time graph is equal to, or will give you the total distance covered. Audrey, are you okay?
Yes, sir.
All right. So then C, Given that u is the velocity of a body at time t is equal to 0, show that the final velocity v of a body when it moves with a uniform acceleration a through a distance s is given by the equation. So here you are proving equation 3. We are only proving equation 3. So we are told that the initial velocity of the body is u. So initial velocity equal to u, then at time t, okay, with an acceleration a distance s. So all that we have to do is that if we are given such parameters, then the acceleration of the body, which is equal to change in velocity over the time interval, okay, or delta t, but the initial velocity is 0, and then the final velocity is v. All right. So if this is the case, then the change in velocity, the change in time will just be t. So change in velocity final minus initial over t gives you this. Then when a body accelerates with an initial velocity u, final velocity v, within a time interval t, having covered a distance s, then the average velocity v bar can also be initial plus v over 2. Okay, the average velocity. Therefore, if we are looking for since velocity is equal to s on t, we can also, since average velocity is equal to total distance over total time taken, we can also connect our average velocity to be equal to u plus v on 2, meaning that we are equating s over t to u plus v over 2, because this is average velocity, this is also average velocity. Okay, if this is the case, then the distance, total distance traveled s will be equal to u plus v on 2 times the time t. Meanwhile, we make the time the subject in equation 1, this equation, which will be t is equal to v minus u over a, and then substitute it into equation 2. So when we do the substitution, we have s is equal to u plus v on 2 times t, which is v minus u on a. Then we apply difference of 2 squared, okay, to simplify the numerator. V squared minus u squared over 2a, so that when you cross multiply, you finally have 2as being equal to v squared minus u squared. And to prove whatever you are asked to determine, v squared will be equal to u squared plus 2as as demanded. So this is what you were asked to derive, and we have done that so well. Any question? Any question? So it's all about determining the acceleration in such a motion, uniformly accelerated motion, of course. Then you find the average velocity. Okay, the concept of average velocity, which is total distance traveled over total time taken, which is also equal to initial velocity plus final velocity, all divided by 2. You equate them, make t the subject in equation 1, and you just play around the equation, you are good to go. Can we continue if you don't have any questions? All right. Let me try the board so we can. Okay. Okay, all right. I'm going through this with some speed because I think it is not so challenging. When we get to questions that will require that I tone down, I will. But you do not keep your questions, or if you have issues with some of them, please draw my attention. All right. Question D. A motorist, please go over with me. Okay. A motorist traveling on a straight road with uniform retardation has a velocity of 15 meters per second at station A and 7 meters per second at station B. If the motorist comes to rest at station C, 70 meters from station B, calculate the I distance between station A and station B. Time taken to move from station A to station B, and the time taken to move from station A to station C. All right. So we are told it is a uniformly retarded motion, meaning that the velocity is expected to decrease within equal time intervals. For uniformly retarded motion or decelerated motion, the velocity of the body is expected to decrease within equal intervals with equal time. So let's try and then plot something on the graph. This is a uniformly retarded motion. The velocity time graph for such a motion, v meter per second, as against t/second. It's a retardation, meaning the body, okay, begins with the maximum velocity and then drops as time goes by. So this maximum velocity, we are told that at station A, this is the velocity, 15 meters per second. So this point must be station A. Okay. Then and 7 meters per second at station B. Yeah, this time we don't know. So let's assume 7 meters per second is somewhere here. Let's assume it corresponds to a time this. So this point is station B, and then comes to rest at station C. So let's join the 2 points. So this must be a point where velocity will be 0, will be on the time axis. Station C. So this will be the velocity time graph, since it's a uniformly retarded motion. Okay. Let me drop the link on the platform. So, 2 points. 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 2 po Some of them already are asking. Okay, Mr. Akman is doing that one. All right. So this will be the motion. Now, we are talking that if the motorist comes to rest at the 70 meter from station B, okay, meaning the distance between station B and station C, 70 meters. Okay, calculate the distance between A and B. Calculate the distance between station A and station. So of course, we know the velocity at A. We know the velocity at station B. We know the velocity at C. We also have an idea of the distance between station B and station C. Okay, so we can use this information to find the that uniform acceleration of the body using v squared is equal to u squared plus 2ax. Okay, now what is v? V is the final velocity at station C. What is u? U is the velocity at B. So 7 squared plus 2 times A we don't know, but the distance between B and C, 70. So quickly use this information to help me get the acceleration of the body from B to C. Please, I'm waiting for you 1 minute. One minute. Audrey, Leonard, let me mention him. Ayo, let's be quick. Caleb, Della, Elizabeth, Frida. Let's be quick. What did you get for A? Laura, I hope you are following. What have you made for A? Ayo. Oh, you are wasting time. Minus 0.35. Sorry. Minus 0.35 meter per second squared.
Yes, please.
Yes, please.
Let's be quick with our responses. Okay, so if this is what we've had for the uniformly decelerated motion, okay, then we can now go ahead to find the distance between station A and station B using the same equation, okay, because we found A. We know the initial velocity at station A. We know the final velocity at station B. We found A. So we can find S. Quickly do that for me. Once we found A, we know V. No, yes. We know U. We know V. We have A. We are looking for S, the distance. Another way out. Okay, you finish with this. So it means S here would be equal to V squared minus U squared over 2A. The distance between station A and station B. So put them in, let's see what you'll be able to get. And then I show you the plan B. Angel, are you there? Are we through? It seems to be slow, so slow this morning. Okay. Elizabeth, what did you get?
Please, I got 251.429.
Come again.
251.429.
251.429.
Yes, please.
Okay, let's see. All right, Henry. Okay, let's go through generally. So if V, okay, if V, the distance between station A and station B, this is the initial, this is the final. Okay, so 7 squared minus 16 squared divided by 2 times 0.35. 2 times negative. So 2 times negative 0.35. And we need to get 251.43 as Elizabeth had. So S will be equal to 251.43 meters. As the distance between station A and station B. Please, is that understood by all? Leonard, Audric, can I continue? Laura, are you okay? All right, the next question. Distance, so we found distance between A and B. Time taken to move from station A to station B. Time taken to move from station A to station B. That's simple. Once we found acceleration and all that. Okay. Once we found the time, the acceleration or that uniform deceleration, I think it must be so simple. It must be so simple. So using equation 1, which is equal to U plus 80, we can find the time. Using V is equal to U plus 80. We are looking for the time taken to move from station A to station B. Initial velocity is known, final velocity is known. That uniform acceleration is also known. So T must be easier. So final 7 minus initial 15 over minus 0.35. Another method, you can use S is equal to U plus V over 2 times T. We found this distance, S. S is 251.43. So T therefore would be 2 times S over U plus V. And so 2 by 251.43 divided by 15 plus 7. Both ways must give you the same time. What do you make for the first one? What have you made for this?
22.86 seconds.
Let's check the time. It said calculate time taken to move from station A to station B. Okay, so 22.86
seconds.
Let's check this. What about using the second method? Using the second method. Are we getting the same thing?
Yes, please. 22.86.
Okay, that's it.
Yes.
So, no matter where you go, if you understand what you are doing, you get the same result. All right. Then the last question: time taken to move from station A to station C. Time taken to move from station A to station C. We found the time A to B. You can also find the time B to C and add. Okay. If I want to go by finding the time taken to move from B to C, then using the same relation, T is equal to V0 minus U7 over negative 0.35 would give me the time taken to move from, okay, would give me, yes, you are right. So this will give me the time taken to move from B to C. Then when I finish, I add whatever I get to 22.86, which is the time taken to move from A to B. Okay. So give me the result for this. That is time from B to C. B to C. B to C. Let's be quick. Let's be quick. So simply 7 divided by
Please,
0.
20 seconds.
All right. That is 20 seconds. So this is equal to 20 seconds. Therefore, time from A to C, time for A to C will just be 22.86 plus 20, which is 42.86 seconds. The plan B, we can also have a plan B, and the plan B is using S is equal to U plus V over 2 times T. Okay, here this time we are looking for the time for station A to station C. The total distance involved you can determine. So the total distance involved could be 251 plus 70. 251 plus 70. And that is 321.43. So the total distance from A to C, 321.43 is equal to initial velocity 15 plus final velocity 0. So basically 15 over 2 times T. When you make this T the subject, you must have the same time as what we've just calculated. So Elizabeth and Co, confirm this for me. Confirm this time for me. T might be 42.8.
Yes, please. 42.86.
Yes. So there are so many ways of solving the problem. Please, any question? Any question?
No, please. No, please.
All right. Then, class, if you have issues, do not keep it. I'm always here for you. And you. Question 2. Question 2. I want somebody to explain the concept of free fall. What is free fall, or what do we mean by a body falling freely? Ayo, I put it to you. Ayo, what is free fall? Just give me what you know about a body or free falling body. Ayo.
Yes, sir.
Do you have an idea of free falling?
Yes, sir.
Okay, share it.
So when we say a body is free falling, that means the body is falling, but without any influence of air resistance or any other external forces.
What is influencing it? You have given me stuff to neglect in free falling, but you haven't told me what actually influences the fall of the body. Okay, Della, let me hear from you too. Della, how do you understand a free falling body? Della?
Please,
Yes.
Okay, go ahead, Della.
What I know about a free-falling object is that it's not opposed by gravity. It falls freely.
All right. Mamiya, your hand is up.
A free falling body is free fall is a concept that says that when a body is left to fall on its own, it's without any external force acting on it from a height.
Okay.
It's only the gravity that acts on it, not any air resistance or any other external force. It will fall on its own.
Okay, Martin, Mamiya. Okay, so listen to a mind version. A body is said to be free falling when gravity is the only force acting on the body in the absence of other forces such as air resistance, friction. Okay, so a body is said to be free falling when as the force of gravity is the only unbalanced force or is the only force acting on the body. Okay, in the absence of other forces such as air resistance, friction, and whatnot. Now, when a body falls freely, you have to explain. So, when a body falls freely, irrespective of the body's mass, the body accelerates with a constant value approximately equal to 10 meter per second squared. Okay, when a body falls freely, irrespective of the body mass, the acceleration of the body is equal to 10 meter per second squared. This is the reason why when two objects of different mass, maybe a feather and then a metal shot, is dropped simultaneously, when these conditions prevail, we expect the feather, as you know, and then the metal shot to drop at the same time, because irrespective of their masses, they are all accelerated by this constant value, 10 meter per second squared. Meaning, a free falling body has its velocity changing, or a change in its velocity as 10 meter per second within 1 second. Please, is that clear?
Yes, sir.
So please take note of the key facts, because whenever we are marking, we will look at these details. A body is said to fall freely when gravity, or when force of gravity is the only force acting on the body in the absence of all other forces such as air resistance and friction and all other forces. Meaning that for free falling body, we don't look at air resistance. It must be neglected. When a body falls freely, irrespective of the mass of the body, okay, the body accelerates by a constant value of 10 meter per second squared, meaning the body's velocity changes, and this is acceleration, increases by 10 meter per second within every second. Okay, and for free falling, a graph of the velocity against time would give you this constant value of 10 meter per second squared. This is the concept of free falling. Any question? All right, let's move on to the next question. If you don't have any issues, a baseball is projected with an initial velocity u at an angle theta with the horizontal. So let me quickly picture. So a baseball is projected at an angle theta. And given an initial velocity u. Then what is the velocity of the baseball at its maximum height? Now, once it is given, it is projected, given that velocity angle theta. It will go, this will be the path of trajectory and then drop. So this will be from ground to ground. From ground to ground. Start from here, drops to the ground, from ground to ground. Now, assuming this is the maximum height reached, that's the maximum height. So from wherever it could reach to this is H max. We are to determine the velocity of the body at the maximum height. So, what is the velocity of the baseball at its maximum height? Explain. Yes, views. Let me pick your views. What do you think will be the velocity of the baseball at the maximum height? Hilda, this question belongs to you. Hilda, what is your view of the velocity of the body at the maximum height? Cadmiel, okay, I've seen what. Hilda, let me hear from you, then we move on to others.
Exactly 0.
0, okay. So you and Cadmiel are the same wavelength. Thank you. Gabriel, what do you also think?
please, 0.
0, okay. More views. Laura, can you hear me? Elizabeth, 0. Laura. Oh, Laura isn't responding.
Sir, please, it's 0.
0. Okay. All right. Della, what do you think?
Yes, please, it's 0.
0. Mami ya busua. Okay. Mpapa 0, right? Mami ya. Mami, are you there? Okay. Oh,
I think that the vertical component will be 0, but the horizontal one will be the same as the one expected. Horizontal velocity.
in fact, all right, Mami, thank you. All those, anyway, Ayo. let me get your opinion. Ayo, what do you also have? Ayo, don't waste time. Okay. All right. Now, if you go for, you see, you are asked to explain. Class, if you go for 0, if your answer is 0, then you are getting 0. if If your answer is 0, you'll get 0. The point is that for projectile motion is such that the velocity, by virtue of it being short angle theta, the velocity of projection u is divided into u cos theta and u sine theta. So when you resolve u with the angle, it is divided into u cos theta and u sine theta. The square of the velocity of projection is actually equal to ux squared plus uy squared. Meaning this is the same as u cos theta squared plus u sine theta squared. Now, u cos theta is constant. So initial horizontal velocity is equal to the final horizontal velocity. So for projectile motion, its velocity horizontal is constant. Initial horizontal is equal to final horizontal, which is equal to u cos theta. Please, do you understand this? Do you understand this concept? Yes or no?
Yes, sir.
Yes, please.
Go say.
For projectile motion, its horizontal velocity. Okay. All right, then I think I need to. You see, let me take the time to quickly take you through this a bit. Conditions on which projectile motion works is that one, air resistance is neglected in all projectiles. Two, gravity, force of gravity does not affect the motion horizontally. So these are this. Now, are the facts. Then, I think you understand the fact that velocity is divided into u sine theta and u cos theta. You understand that fact? Class, do you understand this? That the velocity is divided into u cos theta and u sine theta.
Yes, please.
Okay.
Yes.
Now, if this is the case, we are looking at a body which is being thrown, but it is thrown at an angle theta. Its path or trajectory will be from where it started on, until it drops on the ground. Meaning that as the body moves, when we compare the body's position to its starting point, which is this, assuming it takes the time, the body takes the time T1 to come here, T2, T3, up to total time, which we are calling as time of flight. If I want to determine the displacement of this body, the displacement is that we are comparing how the body has been moved from its initial position, meaning this distance, x1. Now, how do we determine this distance? x1. We are saying that for projectile motion, horizontally, We are analyzing it horizontally, meaning that horizontally is its velocity. When you look at the motion horizontally, because air resistance is neglected, because of gravity doesn't affect motion horizontally, the initial horizontal velocity ux would be equal to the final horizontal velocity. And this will all be equal to u cos theta. It will be constant. Initial will be equal to final because of this condition. Air resistance is neglected. Friction does not affect motions horizontally, meaning that there isn't any variable or factor which can reduce the speed of the body horizontally. So these are the reasons why for horizontally, initial velocity is equal to the final velocity. This is the case, meaning the velocity horizontally is constant. It's constant. It doesn't change. Nothing reduces it. If I want a distance travel, velocity is equal to distance over time. Therefore, S is equal to V times T. Meaning, if I want this distance, x1 travel, is the horizontal velocity and the time. So x1 would be equal to u cos theta times the time taken to come to this point, which is t2. If I want this distance traveled by the body per this position, let me label this x3. x3 would be equal to constant horizontal velocity times the time taken to get to this point, which is t3. If I want this whole horizontal distance traveled, okay, the whole horizontal distance traveled, OX. OX must be equal to the constant horizontal distance u cos theta times the total time taken to move from here. The total time taken to move from here and then drop to the ground. This time is what we are calling as the time of flight. Please, this total horizontal distance I am representing at OX is what we technically call as the range. So the range is the total horizontal distance traveled by the object, the projectile. And the time of flight is the total time taken. Okay, from where it starts to where the object drops. Please, are we okay?
Yes,
Are we
please.
okay? So at any time t, this is how to calculate for the horizontal distance traveled by the body. Now, the body's velocity, okay, vertically, when you analyze it vertically, it changes. Vertical analysis. I wish we can even go through projectile motion. Okay. Vertically, you see, under projectile motion, we are neglecting air resistance, but we can't neglect gravity. Gravity would always be there, but it will affect vertical motion. So when we are looking at the motion of the body vertically, not horizontally, vertically, because gravity affects it, its velocity will reduce. That is why you are saying that when it gets to the maximum height, the velocity will be zero. Velocity will be zero because vertically, gravity is there to reduce it. Okay. So how do we determine the vertical velocity of the body? Using V is equal to U sine theta minus GT. Actually, this is from equation 1 of vertically upward motion, V is equal to Uy minus GT. We are going up vertically. Now Uy is equal to U sine theta minus GT. And so this is the expression we use to determine the body's vertical velocity at any time t. What it therefore means is that for a projectile motion, whatever it is, assuming it is here, there is always two velocities acting on it. The horizontal velocity, which is always constant, u cos theta, and then the time-dependent vertical velocity, that's what v. Now, when it gets to the maximum height, because of gravity, the vertical one goes to 0. So this goes to 0 at the maximum height. At the maximum height. But the horizontal velocity is always constant no matter the position of the body. Okay. So at the maximum height, the vertical velocity is 0, but the horizontal velocity is there, u cos theta. So this must be the answer. At the maximum height, its velocity is u cos theta. And you have to explain. The explanation is that when the body gets to the maximum height, the vertical one goes to 0, but the constant velocity, horizontal velocity is there. Please, is it understood? Is it understood?
Yes, sir.
So it isn't 0 like that. The vertical one is 0, but the constant horizontal one is there acting on the body. So its velocity at the maximum height is equal to the u cos theta. All right. Now, a question on projectile motion properly. See, a projectile is fired upward with a velocity of 80 meters per second at an angle theta. Let me quickly draw it. So what you need to understand is that for projectile, at every point position of the body, there are two velocities, the vertical one and then the constant one. However, when the body gets to the maximum height, the vertical one is 0, but the horizontal one is always constant because gravity does not affect it, because air resistance is neglected. So a projectile is fired upward with a velocity of 80 meters per second at an angle theta to the horizontal from the top of a tower of height 40 meters. So, meaning it is projected from a height. So this tower, the height of the tower 40 meters. Now a projector is fired at an angle theta just to the maximum height and drops to the ground. The angle of projection is theta. Velocity of projection is 80 meters per second. Okay. Now the projectile travels to the greatest height from the tower. Okay, 4 seconds. So we are told that the time taken to reach the maximum height, the time taken to reach this maximum height, this t is given as 4 seconds. All right. Calculate angle theta. Now, under projectile motion, we are just solving questions. So I'm going to use some of the formulas straight away. Time taken to reach the maximum height is given by u sine theta over g. Okay, because vertically, to determine the vertical velocity at any time t, v is u sine theta minus gt. The equation I just derived. But we also know that at the maximum height, at maximum height, vertical velocity is 0. So if v is 0, we equate this to 0 and make t the subject. You have the expression for the time taken to reach the maximum height. Which is, so this is the relation I'm using. Because we have u, 80, then we have this time. The time taken to reach the maximum height, we are told is 4. So 4 AC sine of theta over which is given 10. We can easily find theta. So sine theta will be equal to 4/8, which is half. If sine theta is equal to half, then theta is equal to 30 degrees. So this is the answer for theta. What is the maximum height reached from the ground? Listen, maximum height reached from the point where the projectile is thrown. This is the maximum height, H max. But maximum height reached from the ground, meaning we are going to add this to the height of the tower to get the maximum height reached from the ground. So let's calculate H max. As for the height of the tower, we know this is 40. But especially for the maximum height, using v squared is equal to u sine theta squared minus 2jh. You can find this expression. At the maximum height, v is 0. So if v is 0, v squared, 0 squared is 0. Then we make h the subject. H will be equal to u sine theta all squared over 2g. We have u sine theta. U sine theta is equal to 40. 80 times sine 30. Sine 30 is half. So we have h being equal to 40 squared over 2 times 10, 20. So 1600 over 20. And this is h, the maximum height reached by the projector is equal to 80 meters. Good. So if 80 meters, then the maximum height reached from the ground will be 80 plus 40. Therefore, maximum height reached from the ground. is 80 plus 40, which will give us 120 meters. That will be it. Please, any question before we move on to the next question? Time of flight. What is the time of flight? The time of flight is the total time taken from start to when it drops on the ground. Now, we've determined, or we are given the time taken from the point of projection to the maximum height. So we will need the time it will take to move from here to the ground. So when we add that to the maximum height, we have the time of flight. So how do we determine this time, the time to move from the drop to the ground? Using, you see, when it is dropping from the maximum height to the ground, the body is free falling. And if it is free falling, then the initial velocity u is equal to 0. So using h is equal to u sine theta plus half j t squared. Already this u is 0 because the body is free falling when it is dropping from the maximum height to the ground. So if u is 0, then h would be equal to half j t squared. What is h? H is this height from the maximum height to the ground, which is 120. So we have 5. 120 on 5 is equal to t squared. Please help me determine t. Help me find t. And then it's 24.
Please, 4.9.
Come again.
Please, 4.9.
95. 10.95, sir.
Okay. Second. So, if the time taken to move from the maximum height to the limit is this, then time of flight would be equal to time taken to reach the maximum height plus this time 4.95. And the time taken to reach the maximum height, we are told is 4. So our value will be 8.95 seconds at the time of flight. Please, understood?
Yes, sir.
All right. The next question. The next question says that as for range, the range must be simple because range is the total horizontal distance traveled, and we are talking about this distance. Okay, from wherever it is to the landing point, or from here to here, the range is equal to u cos theta, which is constant, times the time of flight, and 80 cos of 30 times time of flight of 8.95, and you are good to go. Mommy, yeah, what have we had for the range? What have we had for the range? When you calculate? Oh, calculate it for me. 80 cos 30 times 8.95.
624. 620.07.
Okay, so 620 points. Okay, I think approximately 620. Then velocity of the projectile when time is 2.0 seconds. Velocity of the projectile. But this is the velocity of the projectile when time is 2.0 seconds. When t is equal to 2.0 seconds. The question I have for the class is this. At t is equal to 2.0 seconds, what is the location of the body? Is it at the maximum height? Is the body yet to reach the maximum height or dropping to the ground? Or from the maximum height dropping to the ground? At this time, what is the position of the body? Okay. All right.
Close to reach the maximum height.
Okay. iPhone. Okay. It's yet to reach the maximum height. Why? Why is the body yet to reach the maximum? What informed your decision? How do you know that the body is yet to reach the maximum height? How do you know? Those of you who answered that it is yet to reach, how do you know that it is yet to reach the maximum height?
This is because at the maximum, it took 4 seconds to reach the maximum height.
Thank you.
And
Ayo, thank you. So usually the use of this equation is this. I'm asking this question because when the body is moving up, the velocity equation used okay, Audrey, I'll check and see. When the body is moving to the maximum height, moving up, the velocity is u sine theta minus dt. And whenever it is moving from maximum in between maximum and dropping, we determine the velocity by u sine theta plus dt. Okay, the body decelerates when it is going up, accelerate when it is coming down. But how would you know what it is deceleration or acceleration? You need to check the time given. If the time given is less than the time taken to reach the maximum height, then then it means the body is not yet at the maximum height. If the time given is more than the time taken to reach the maximum height, then it is accelerating, dropping down. Okay. So how do we determine this time in question? How do we determine this time in question? I just told you that apart from the maximum height, there are two velocities. U cos theta, and then the time dependent velocity. Okay. Meaning that this question of what is the time taken, what is the velocity of the body after time of 2 seconds? It means there will be this, there will be this, Okay, now this vertical velocity when we resolve. Determine the resultant using Pythagoras theorem. So the resultant V will be equal to U cos theta squared. The velocity, the resultant squared will be V is equal to U cos theta squared plus the vertical squared. Find U cos theta. U cos theta is 80 cos of 30. So 40 roots of 3 squared will give us this. What about Vy? Vy using U sin theta minus dt. And so, what is U sin theta? U sin theta 80 times half. So 40 minus 10 times 2. Gravity is 2. The time in question is 2 seconds. So the vertical one is 20. Okay. Now, because they are related to the Pythagoras theorem, it means that V would be equal to square root of U cos theta gave us this 40 root 3 squared plus 20 squared. When we put them together, we have square root of 1600 times 3 plus 400. Please put them together and then give me the final answer. Put them together and give me the final answer. What's the final answer?
72.11.
Okay, so 72 points. So this is the velocity of the body after time t is equal to 2 seconds. So you need to be very, very, very careful. Okay, if the question had been, what is the vertical velocity after time of 2 seconds, we are going for this one, the vertical velocity. This one. What is the vertical velocity after time t is equal to 2 seconds? Then the answer would have been 20. But when the question goes like, what is the velocity after 2 seconds? Then you shouldn't lose sight of the fact that for projectile motion, at every point, there are two velocities. Constant horizontal velocity and independent vertical velocity. So you need to find the two and find the resultant. Class, are you okay? Are you
Yes,
okay? It's a bit technical. If you are not careful, it can easily floor you. All right. If you have any question to ask, if you have any question. All right. Then let's move on to state the principle of flotation. We have to state the principle of flotation. I'll throw these questions to you randomly. And Hilda will start. Hilda, tell us what you think about the principle of flotation. We are stating. Oh, Hilda, I'm waiting for you. Anna Hilda has gone to sleep. Okay. Ato Kwame na. Ato. Leonard, take over and let's go.
Oh my God.
Leonard.
What physics is this? Physics is gonna kill me. Physics will kill me.
Oh, everybody is quiet. Audrey, mute yourself for me. Okay, Mamia. Mamia.
The law of flotation says that a floating body displaces its own weight of the fluid in which it's floating.
Perfect. Perfect. Okay. Audrey, what do you also have to say about the law of rotation? Audrey. Okay, Ayo. Tell us what you also think. Something.
The law of flotation. It says that when a body is inside a liquid, it displaces the weight of the body is the same as the weight of the liquid displaced.
You are giving us the what concept of rotation, but the law, the law itself, putting words to describe the law is a problem. Okay, so you are right. Please, class, whenever you are called upon to answer a question, we are learning. Okay, so feel free to express your views, your opinion. You may not be exactly on point, but where a teacher calls and then the response isn't coming, is not the best. We are learning. Mistakes are part of the process. Okay. So the law of flotation says that a floating body displaces its own weight of the fluid on which it floats. Just as Ayo and Mamia said, a floating body displaces its own weight of fluid. Okay, so it just displaces fluid which is equal to its own volume. The reason for which Ayo is saying that when a body floats, its weight is equal to the weight of the fluid it displaces. A floating body displaces its own weight of fluid on which it floats, the body floats. Meaning weight of the body must be equal to the weight of the liquid display or the actress. So anything which floats with the body of that anything, whether a hydrometer, ship, submarine, the hot air balloon, name them, anything which floats, yacht, whatever, weight of body can be equal to the weight or liquid. Okay, let's use fluid because the fluid can be gas as well for hot air balloons. Weight of fluid display. You can also say that for a floating body, the weight of body or the object must be equal to the atlas or the upward force. That's all. Mention two applications of the principle of flotation. I've mentioned about three. Ship, hydrometer, submarine. Okay, Henry, your hand is up. Balloon. So in this particular situation, Henry, let's use hot air balloon. Okay. The hot air balloon ships aeroplanes float in air, and they also displace air, which is equal to their weight. All right. An ordinary hydrometer of mass. Please, did you do fluid mechanics at school and then talk about flotation?
Yes.
Yes, please.
Okay. So then let's an ordinary hydrometer of mass 20 grams. So mass of hydrometer. We are told is 20 grams. Float on brine. Float in brine of density 1,200. So the density of the liquid brine is 1,200 kilogram per cubic meter. Then calculate the volume of the hydrometer submerged in the liquid. Leave your answer in centimeter cube and listen. In JHS, you were doing this experiment where you want to determine the volume of an irregular object. And what you were doing was that you fill a measuring cylinder with liquid, indicate the initial volume, V1. If the irregular object is a stone, you tie the stone, okay, using a thread, lower it gently into the measuring cylinder. Then you record the final volume after the displacement. And you said volume of water displaced is equal to final volume V2 minus initial volume V1. And this, you are saying that this is the volume of the irregular object. Object is equal to V2 minus V1. Then this is used to determine density. So weighing to get the mass, then you divide the mass by this, and you are saying that is the density of the irregular object. All that you are doing is that when a body is immersed in liquid, the volume of the liquid displaced is equal to its own volume. So if it is half of the body that is immersed, the volume of the liquid displaced will be half of the object volume. All right. So we are asked to calculate the volume of the hydrometer submerged in the liquid. But one thing, a hydrometer floats. Hydrometer floats. And so we apply the law of flotation, which is this. Weight of body equals weight of liquid displaced. Now, instead of weight, we can also express it in terms of mass, because weight of a body is mass of a body V times gravity, acceleration with gravity. Then weight of liquid fluid displaced can also be mass of the fluid times gravity. and gravity is constant on the surface of Earth. So G will cancel out. So we have mass of body to be equal to mass of fluid displayed. So the law of flotation can also be stated in terms of mass, that when a body floats, the mass of the body is equal to the mass of the fluid displaced. Okay. Mass of the fluid. Don't forget, mass can be expressed as density times volume. So this mass of the fluid, we can also represent this by density of the fluid times volume of the fluid. The question gave us, what are we to determine? Oh, okay. We are to determine, so if the mass of the hydrometer is 20, so mass of the body, which is the hydrometer, is 20, is equal to density of the fluid, 1,200. Since I'm not changing this to kilogram, then I must also express the density in gram per cubic meter, gram per centimeter, cubic centimeter, and that would also be 1.2. So a density of 1,200 kilogram per cubic meter is equal to density of 1.2 gram per cubic centimeter. If it's 1,000, it will be 1 hour. When I manage to find the volume of the fluid displaced, so volume of the fluid displaced will be equal to 20 over 1.2. What is 20 over 1.2? 20 divided by 1.2. Quick one. Quick one.
16.667.
So 16.667 centimeter cube. After all, we're asked to leave our answer in centimeter cube. Leave your answer in centimeter cube, so this is the volume. Now the volume, we earlier said that when an object is immersed in fluid, the volume of the fluid displayed, fluid can be liquid or gas, also equal to the volume of the object. So this is the volume of the hydrometer immersed. I hope that's okay. I'll be sending you challenging questions on this. C, please, any question? Any question? Okay. C, an object of mass 80 gram and density 12 gram per cm cube is suspended by thread and lowered until half of its volume is immersed in a liquid of density 0.8. Calculate the weight of the object in the liquid. Okay. Calculate the weight of the object in the liquid. So here we are looking at the atlas. Body suspended, immersed in a liquid. When the body is immersed, okay, in a liquid, then there will be upthrust action on the body. So let's quickly go through this theory. We have a spring balance, obviously, to determine weight. So if this is the object suspended, the spring balance records the weight of the body in air. So this gives us weight in air. When the same body is lowered into a fluid medium, because this is a fluid, an upthrust, an upward force acting on the body, and so that would reduce the weight. Okay, so this reading would give you the weight of the object in liquid. So we have weight in air, which is W real, the real weight. The object weight in air is its real weight. When weight or immersed in fluid, we have the object apparent weight in liquid. This is equal to apparent, W apparent. The apparent weight, okay, Julian, go ahead. Julian, not your
please,
question.
I thought the object. Please, the question said the object was lowered halfway.
No, we are not solving it yet. I'm taking you through the theory a bit. Okay. All right. So the apparent weight is always a little bit less than the real weight. And supporting that, the apparent weight from the real weight gives an upthrust. So the upthrust is equal to real weight or weight in air minus weight in the liquid, or W real minus W apparent. So these are the expression for upthrust. Another way, so this is actually what we are looking for, meaning we need to know the real weight and the upthrust to calculate for the apparent, right? What we need to do this? The spring, when immersed in fluid, okay, the upthrust act on it, so is the original weight, the weight of the body. Another force, which is the tension in the spring. The tension in the spring always is directed to where the support is. So the tension in the spring is also another force acting on the body. So when you sum up total forces upward and then downward, you have weight, the real weight of the body equal to this weight equal to the tension in the spring plus the upthrust. Don't forget the upthrust and then the tension are in one direction. Okay. And so when you make T the subject form, you have W minus U. From equation 1, this is 2. Equation 1, when you make apparent with the subject, W is also equal to the real weight.
My earpiece is off. Let me use my voice. So please pay attention. All right. Can you hear me?
Yes, please.
So from equation 1, the apparent weight is also equal to the real weight minus upthrust. Compare these two. The deduction we can make is that, oh, okay, then apparent weight, W apparent, is always equal to the tension T, tension in string or spring. Whenever an object is lowered in a fluid. So the apparent weight, which is also the weight in air, is always equal to the tension in a string or spring when an object is lowered. Then let's come back to the question. So meaning to find the apparent weight, which is the weight of the object in a fluid, it must be equal to real weight of the body. Do we have the real weight? We are told that the mass of the object is 80. So mass is 80. And we are 80 grams. We have to express this as weight. So 80 grams converted to weight is times 0.01 Newton. Maybe you are confused. Don't be confused. And I'm picking it from this. One kilogram mass would give you a weight of 10 Newton. Okay. Mass times acceleration due to gravity. So 1 times 10 Newton. What mass would 1 gram? What will be the weight of 1 gram? Don't forget, 1 kilogram is equal to 1,000 grams. So meaning that the equivalent weight of 1,000 grams would be this 1 gram is 1 gram would be 10 divided by 1,000. 10 Newton divided by 1,000. Okay, if 1 kilogram gives you a weight of 10 Newton, then 1 kilogram is equal to 1,000 grams. Therefore, 1 gram will be when you've divided through by 1,000. So this is 0.01 Newton. The next way out is that, okay, if you want the weight of 1 gram, convert 1 gram to kilogram, and that will be 0.001. Okay, 1 gram is equal to 0.001 kilogram. Then the weight of 1 gram will be equal to the mass, which is 0.001 times 10. And that will be it. So when you give me mass in gram to convert to weight, because of this, I'll just multiply the mass by 0.01 Newton and wouldn't convert it to kilogram before. It's a waste of time. Because if 1 kilogram is equal to a weight of 10 Newton, then 1 gram will be 0.01. So X gram, that X quantity times 1, the weight of 1 gram, I'm good to go. So this is how, the reason why I'm multiplying 80 gram by 0.1 Newton direct. So apparent weight would be the real weight, which is this minus the upthrust. Minus upthrust. What is upthrust? Upthrust is weight of fluid displaced, which is equal to mass of fluid and gravity. Mass of fluid is also equal to density times volume. So upthrust will be density of the fluid, volume of fluid displaced times gravity. Okay, so this is actually mass. What is the density of the fluid? The density of the fluid is 0.80. So 0.80 times the volume of the fluid displaced. You see, we are told that half of the volume of the object is immersed. So what is the volume of objects? Volume of objects. We have the mass of the object and then the density. Okay, so volume of object will be the mass 80 divided by its density, which is 12. And what is 80 divided by 12?
6.67.
80 divided by 12, we have 6.667. So if this is the volume of the object, 6.667, this is centimeter cube. Then half of this object is immersed, and that would also be the volume of fluid displaced. So volume of fluid or liquid displaced will be equal to half of the volume of the object, 6.667. Okay, so this 6. Can you calculate it for me? Can give me the answer. My calculator isn't helping me. 6.667. And then it's 3.33 cm cube. 3.333 cm cube. Okay, so this will be the volume of the liquid displaced. 3.333 times 0.01, because this is mass times gravity. So mass expressed in gram times this. Calculate this for me. 0.80 times this times 0.01. I think the answer is 0.02664. 0.02664. 0.02664 Newton. This is the upthrust. Therefore, the apparent weight or the weight of the object in fluid would be equal to its weight in air, which is 0.80 minus 0.02664. And our final answer is 0.77334. 0.77334. So this is the apparent weight of the object in fluid. This is the apparent weight. Please, any question? So it's a step by step thing. Okay, I'll go through, I'll look at some of these concepts. Hot air balloon, how the hot air balloon works. Okay, then we look at, I think, flotation. We'll look at flotation again. Okay, give you my explanation of this concept. Then, so as to help shape your understanding. Okay, we have a simple question on vectors. I think the vector question isn't so difficult, so I'll give that as an assignment. I want you to look at question B. As for question C, it is just simple. Two vectors perpendicular. That is simple. Okay. So your assignment is question B. 4B. A man travels 30 kilometers, 30 degrees north of east, and then travels 20 kilometers due north. With the aid of a diagram, calculate the magnitude and direction of the displacement of the man from his initial position. And I'm going to pin you, and that is, you have to use two different methods to solve this. Use two different methods. In fact, you can even use three, but I'm only restricting you to two. Use two different methods to solve this question for me on vectors. Please, class, is that okay?
Yes.
Hello,
please.
is that clear?
Yes.
Yes, please.
All right. So I'll be expecting, please, your assignment page. Those of you who have been with us can still use the old page. The old page, okay, through which assignments are forwarded. Use that. If you are new, I'm sure during the orientation you were taken through forming of assignment page with the teacher. New ones, let me see you. Old ones, use it. Send your works through your page for marking. This is where I draw the curtains on today's meeting. As usual, I'll be uploading today's video so that you can always, revisit to make corrections to help better understanding. May the good Lord be with you. Take care of yourselves and your assignments. Bye-bye. We'll meet on Friday.
Bye.
Bye.